Parallel circuit practice using the verb table. Three resistors R1, R2, and R3 are connected in parallel. A voltage V provides the energy for this circuit. This diagram shows the current flowing from R1, R2, and R3 and the total current in this circuit, which is IT. The first equation indicates that the total voltage in a parallel circuit is equal to the voltage drop V1, which is equal to the voltage drop V2, which is equal to the voltage drop V3. This can be verified by just connecting the lines. The terminals of each resistor are connected to the terminal of the voltage source, and they are connected with each other. The total current is equal to the sum of current at each joint. And the total resistance or equivalent resistance is equal to the inverse of the sum of each resistor. So let's complete the column for total resistance. So we have here the value for R1 is 10, R2 is 20, and R3 is 30. To calculate the total resistance, you need your calculator, the inverse key. When you find the inverse key, so you are going to type 10 and hit inverse, plus 20, hit inverse, plus 30, hit inverse, and then hit equal, and the result you are going to inverse one more time. So you should have a value of 5.45 ohms. Now, let's take a look on the voltage column. So because the voltage on parallel circuit is the same across, so we are just going to repeat here. The voltage on R1 is 6, the voltage on R2 is 6, and the voltage on R3 is 6. So now we can calculate the current that is flowing on each resistor using the equation for Ohm's law. The current is voltage divided by the resistance, and we can use for each one of the values here. So for this column, the current for R1 is V, which is 6 over 10, 0.6. R2 is 6 over 20, 0.3. And R3 is 6 over 30, which is 0.2. To determine the current, the total current, you can also use the value of the total voltage over the total resistance and calculate the value of total current, 1.1. And you can notice that 1.1 is equal to the sum of the partial currents on each branch. We call branch because is a individual section of your circuit. Now to calculate power, we are using the formula V times I. And for the first one, 6 times 0.6 is 3.6 watts. And for the second one, 1.8. The third one, 1.2. The last one can be calculated by adding all these or using the total voltage and the total current to determine the total power. So the power means the energy dissipated by unit of time. And in this case, because they are just resistor, this power is being used as heat only, thermal energy.